So the stack, we call this is the concept of last in, first out. So what does it mean? So we will look at the abstract data type, the basic definition of stack, and then we will look at the example of stack and how we can use stack to optimize the complexity. We call it this is last in, first out, or sometimes in the logistics we call it LIFO, LIFO. The abstract data type, ADT, is an abstraction of a data structure. Abstraction. So it means we want to make some template or we want to make a blueprint and we can apply to any different application. So the ADT specifies how the data stored, what is the operation on the data, and the error conditions associated with operation. So the example of editing is to do the modeling of simple stock trading system. So for example, the data stored are buy or sell the orders. And then the operations supported are buy. Let's say I have the method buy, and then the argument is stock, share, and price. So I want to buy how many stock, what is the stock, and how many shares, and what is the price. Or sometimes I want to sell. So what is the stock, and how many shares, and what is the price. Or I can also do cancel. So I can cancel the order. I can cancel the buy, or I can cancel the sell. And the error conditions means I should make a condition where the buyer sell with non-existent stock. If the stock is not exist, give the error message. Or if the share of the stock is already empty, let's give the error message. Or we can do also cancel, but if we cancel a non-existent order, it means error. There is no order, but we want to cancel. Then we need to give the error message. So the abstract data type should contain at least these three. So we need to know what is the data, and then what is the operation, and what is the error. So the stack ADT. Okay, so this is the first ADT that we will learn. The ADT stores the arbitrary objects. Arbitrary means any objects. It can be numbers, it can be string, it can be maybe object from the OOP, and etc. So it can be anything. And then the insertion and deletion follow the last in, first out scheme. We call it this last in, first out. Think of a spring-loaded plate dispenser. So usually people will do something like this kind of simulation. So the main stack operation, there are two: push and pop. Push means we want to push an object or we want to insert an element. At the first time, we want to push. Yeah, at the first time, we have only one element, element number one. And then we want to push element two into this stack. We want to say this is the stack. So at the second stage, we have the stack with element 1 and element 2. We want to push element 3. Then at the stage number 3, the stack contains element 1, element 2, and element 3. We push element 4. Then we have the element 1, 2, 3, and 4. We push element 5. Then we have the element 1, 2, 3, 4, 5, and then we put the element 6 at the top. Now, we have another operation which is pop. Pop means remove and return the last inserted element. Because we already have the stack like this one, when we pop, so we will remove the top element. We have 1, 2, 3, 4, 5, and then we want to pop. So when we pop, it means we want to remove the top element. Again, we have 1, 2, 3, 4. When we do the pop, we want to remove the top element. We have 1, 2, 3, 4, and 1, 2, 3. So when we do the pop, we will remove the element number 3. The last one, when we do the pop, so we remove element number 2. So at least there are 2 operations, push and pop, and then there will be auxiliary stack operations. You know, auxiliary means addition. So something to be added. So we can have some addition stack operations. For example, I want to know the top. The top means I want to know the element at the top of the stack. So it returns the last inserted element without removing it. So I want to know what is the element at the top of the stack. The other is the length, and it will return an integer. So it returns the number of elements. If it is, if I'm now in this state, so if I want to check the length, then it means the length is 1, 2, 3, 4, 5, 6, and is empty. It will be a boolean, indicates whether no elements are stored. So we want to know whether the element empty or not. Now let's see this example. Let's start with S, and let's assume we use array with the list, and S equals to empty at this time. I have S dot push 5. Then now the element 5 has been added into the list. I have push 3. Then push is we have something like this one. At first we have 5, and then we push 3. So 3 will be at the top. We can represent with different ways, like this one. It means 5 is the first element, and then 3 is the last element. If I want to know the length, what is the length? Okay, the length is 2, because we have 2 elements. So the return value means something that you can see. But here is the content. Now I want to pop. What is pop? It's I want to remove from the array. So the removal will take place on the first, the top element. The top element or the last element is 3. Then 3 will be removed, and the element now only 5. remains in the stack. And then I want to check. S is empty. False. Why? Because we still have one element. It's the pop. So pop means I want to remove the element because we still have 5 here. So we want to remove 5. Then the return value will be 5, and now the array will be empty. If I want to check S is empty, okay, the return or the return value is true because the stack now is empty. S4. Can we do the proof? New. Because we don't have externals. Because here is empty. And it will be error. So you need to give some kind of error message. So let's just put this error like this. And then I want to add a new element. Second. So the new element is 7. And then I want to add a new element, which is 9. So 7 and 9. I want to know the top. The top is 9. Stack content will remain the same. And then I want to push 4. So 4 will be added. 9, 4. I want to know the length of S. So we have 1, 2, 3, and we can get the result 3. Means I want to remove the top element. So the top element is 4. 4 is removed. Now it becomes 7 and 9. So I want to push 6. Then the result will be 7, 9, and 6. And I have another push, which is 8. So 7, 9, 6, 8. And I want to pop. So the pop is 8. Then the remaining of the stack will be 7, 9, and 6. So there are at least 5 operations. The main operation is push and pop. And the additional operation is top is empty and blank. Okay. So push means we want to add the data. Pop means we want to remove the data. Top is to check what is the element at the end of the array or the top of the stack is empty. Is to check whether the element empty or not. And length, we want to know how many elements are there in the stack. So at least 5 methods in the stack ADT. So the application of text, you can see the direct applications such as page visited history in the web browser. So if you go to the web browsing like Chrome, Microsoft Edge, and etc. So once you visit one page, if you move to another page, then it is stacked. Because if I want to go back to the previous one, then you can just remove it. Or we can also check the undo sequence in the text editor. So in the editor, you have the undo. Undo means you do something and then you cancel what you want to do. Chain of methods calls in a language that support recursion. So in the recursion, we can also use like this kind of step. Some indirect application, for example, this is the auxiliary data structure for algorithms. So there are many algorithms that can apply in the stack to make it more optimal, or it can be also a component of other data structures. So stack can be added with array, or stack can be combined. Stack, later we will learn about the queue and so on. So the stack with array. Okay. Oops. Okay, let me see here. Let's have a break. I will continue after a break.